current electricity maximum power theorem, we are going to deduce the expression or condition under what condition maximum power will be drawn from the source. As you know, maximum power will be drawn from a source, or that condition is your external resistance must be equal to internal resistance. And mathematically we are going to deduce this condition. Now let us consider a simple circuit. EMF E, internal resistance R, external resistance capital R, and I current flows here. Then current I equals to, and if I take, that is, as you know, that is voltage divided by resistance, and if you take total voltage, that is actual voltage, that is nothing but EMF, that is your E, divided by, in that case you have to consider the total resistance. It means internal resistance as well as external resistance, that is R plus R. Now you see, so I is this much. Again, you know that power expression is given by your I square times R. That is, power equals to I square R and I is equals to E by R plus R. Now put the value of I here. That will be E square by R plus R whole square into R. Just you write it, E square R divided by R plus R whole square. This is your power in terms of E total or actual EMF or EMF of the battery. Now you see, simple concept of derivative known to us. Whenever some function has maximum or minimum value, at first the first derivative must be 0. After that, at some point first derivative 0 and second derivative becomes negative at that point. That's a point of maxima. So we are not going to do in details. Simply what we will do, we will find out first derivative of p and we will put that first derivative equal to 0, and from there you will get the point of maxima, and that's the your condition for which the source will, or the from the source maximum power will be drawn. So now what is left? Simple mathematical part is left. Differentiating P with respect to capital R. Now there may be a confusion with respect to capital R or small r, or by what we have to differentiate. By always differentiation with respect to variable. Here which one is variable? This external resistance. When you will fix the source, the internal resistance of the source is fixed, but you can vary or you can change this. That's why we have to differentiate this with respect to external resistance R. Then quotient rule you use, dP dr equals to, denominator is whole square, then you will get R plus R whole to the power 4. Derivative of numerator, that is this formula we are using, U by V whole dash equals to V square U dash V minus UV dash. So derivative of this, E is constant here, EMF of the source is constant, and this will be only E square, because derivative of R with respect to R is 1, into V, this denominator is V. So V as it is R plus R whole square minus, next U into V dash, U means this part, so this as it is, E square R, so E square R, and derivative of this, so twice of R plus R, this you will get, twice of R plus R. Again, if you differentiate this, then you will get 1 here, so up to this. Now let us simplify this. R plus R common here you see, so R plus R you can take common into, here E square times R plus R, one factor will be left, minus twice E square R, and R plus R common, whole thing divided by R plus capital R, that is external resistance, whole to the power 4. Now see here, let me write it. Implies dP dr dp dr equal to, one factor will be cancelled out, and if you multiply this e square r plus e square r, you will get e square r minus e square r minus 2e square r. So here you will get minus e square capital R divided by r plus capital R whole cube, because one factor cancelled out. Now it's almost over. Just you write for maximum value. For maximum value, dp dr must be equal to 0. This will give you e square r minus e square capital R divided by r plus r whole cube is equal to 0. So as you know, if a by b equal to 0, then the numerator must be 0. So from here you will get e square r minus e square capital R is equal to 0. This gives you implies e square common within bracket r minus capital R is equal to 0. So e square cannot be 0, therefore r is equal to capital R, or you can write r is equal to this. So it means when external resistance is equal to internal resistance, under that case, this is the point of maximum. In that case, maximum power will be drawn from the source. This is your condition. R external resistance is equal to this. So after this, now you can rewrite the expression of power, that is expression for maximum power. So let me write here. See, already we have seen that power is equals to E square divided by your R plus R whole square, R plus R whole square into your external resistance R. This is the expression of power. Now you see, in this expression, if you write that R equal to small r, that is external resistance equal to internal resistance, then what do you get? E square into R divided by, it will be twice R whole square, which is equal to E square R divided by 4R square. Now one factor R cancelled out, then this is your maximum power expression you have got. One factor cancelled out, E square divided by your 4 times R. This is the expression for maximum power. That is EMF of the source, EMF square divided by 4 times of the internal resistance.